All right. So let's go ahead and tackle some mechanics about stuff that I was, just to be clear. So we are finally approaching the end of the semester. I'm sure you're all feeling it and are ready for summer break. Okay. So I started running through the grader. I hope to be able to finish running through the grader tonight. I'm not sure if I'll import all the the Runestone grades. So let's go through each grade category and talk about them, right? I'm running the grader again to grade all the stuff there, and then I plan on importing it either tonight or tomorrow, depending on time and other stuff. So that's, again, the solo exercises, as long as they get done by the end of the semester, which is the 28th, you'll get credit for them. Now, that being said, I generally run that grader the final time not on the 28th because I'm busy, right? On the 20th, so if you want to, ideally you should have it done, but let's just to be realistic about things and transparent, 28th, you turn in your final projects. Your exam is on the 1st, right? Let's go and figure out the finals and work back from there, right? Final, exam, schedule, April 30th to May 6th. Our time is, let's see, 2 to 3:20, right? And even though it says 3 credit hours, and our course is a 4 credit hour, right? We look at the 3 credit hours because we're 3 lecture hours. So this is the slot. We don't have a slot here on the 4 hours that would make sense. So it's here. Tuesday, Thursday. So our exam is Thursday from 1 to 3. And then I have to go and proctor my other final at 3:30 to 5:30. So I'll be busy that day. So I'm probably not going to be running the grader on Thursday, right? You have your exam on Thursday. And because your exam is on Thursday, let's just go through the calendar. Because your final exam is on Thursday, May 1st, on the 29th, because the best final projects get exempt from the final exam, that means I get to spend all of the 29th going over your final projects. So I can send out exemption notifications so students know whether or not to spend spend Wednesday studying, right? Make sense? So I'm probably not going to run the grader Tuesday or Wednesday. So the grader will probably be run sometime when I actually have to get grading done or get final grades in, which will probably be Monday or Tuesday of there. So have your textbook in. It's due here, but if you want to play it risky, it'll probably won't run it until this time. Okay, makes sense? This is true for all the in-class exercises as well. Got it? Yes?
For DRS students, how will we go about scheduling?
You schedule, so for DRS students, are you talking about for the final exam itself?
Yes.
Yeah.
In case we need to take it.
You let them know what the normal time for the exam is, and then you notify me, and then you make a request as to when you want to take it. I'm, as you may have found out, very flexible about this, so I don't care if you take it a few days ahead of schedule or a few days behind schedule because accommodations can be a bit weird sometimes, or scheduling for accommodations can be a bit weird, right? So that's fine with me. You just schedule it and let me know and I'll approve it. Okay. Okay. So I still have to grade the DRS question exams from exam 2, I believe, but and I have notified your TAs to put in the grades for exam 2. I'm not sure why they hadn't yet. I think there were a few fields that were called exam 2 and they weren't sure which one to put it in. So okay. So that being said, so again, working backwards from that and going by category. So that's 15% of your grade right there for your for those exercises. Okay. And if for some reason you feel like you should have gotten credit for something because you did it and the system says you didn't, just let me know and I'll manually fix that, okay? Next, lab assignments, right? Those, you know, we haven't had a new one since PIG, so, and you will not have a new one since PIG. So demo those ASAP when you get the chance. Well, ASAP. When you get the chance is kind of contradictory, I guess. Yes.
Where are those against
The 0.1s on the, yeah, those are just, those are basically leftovers from when I first introduced them. They aren't actually assignments, they're just simply, they're directions to take your final project.
And we don't get any credit for it.
Right, right. On a previous, when I first introduced them, I had done them as a replacement grade, but that was a number of years ago before I did the final project. Okay. Yeah, so get but the regular expressions that can be turned in for extra credit.
But not
Yeah, not the Pokemon stuff. Okay. Other questions? Yes.
For my Broodstone, like I did like maybe 5 or 6 assignments, and they all were not like updated.
Yep. They won't update until I'm running the grader, and I just started running the grader again today.
got it,
Yeah.
okay.
Yes.
Sorry, I was trying to get my stuff filled up, I missed it. How much,
How much what?
I don't know, it's something about I'm sorry, I'm all over the place.
No worries. Get back to me when you think of it. With regards to the, let's see. I will cover the overall by the way, I'm just trying to go through the breakdown of the grades right now. Then your final project is worth another 10%, right? So you've got 25 from your lab assignment, you've got 5% from your in-class exercises, 10% from your solo exercises. So that gives us a total of 40, then the 10% from your final exam. That will be 50%. Sorry, not your final exam, your final project.
What about exam 3?
I'll get to that in a second when I'm covering exams. Final project, again, that is due the 28th. Turn in what you have, regardless of whether or not it's done or not. I want to see what progress you did make on it, okay? And again, you'll have a progress report to turn in. I believe that's due this upcoming week. If you have not told me what you're doing yet, or if you've not gotten approval about what you're doing yet, come up to me after class and fix that, okay? Yes?
Okay, so, I had 2 questions now. So the choose your own adventure, this is extra credit, yes?
No, that used to be extra credit, the choose your own adventure.
Okay, and my second question, I'd like to go over the proposal. I know I talked to you about it the other day, but
Yeah, if you want to double check something, I can meet with you after class.
I'd like to be very confirming with what I'm doing, just to make sure that.
Yep, if you turned in a proposal, you're in the, and I said yes to it, you're in the clear. Okay? And with your particular case, I know you're in the clear because you've talked to me multiple times throughout the semester.
I changed my idea over
That happens. Yeah, this stuff, choose your own adventure, this stuff used to be extra credit. I'm not sure why, does it say that it's extra credit? Yeah, building blocks for the final, project. Okay. So if I pull up the syllabus again, let me go ahead and pull up the syllabus for a second. Okay. Right? The exams are worth 30% of the grade. We have 3 exams, but they're not worth each 10% of your grade. Instead, again, we've got 3 exams, 1, 2, 3. The third exam, think of it as a makeup exam or a bonus exam. The point of it is that so that we can give you the chance to replace your lowest grade so we take the top 2 of your 3 exams. Make sense? And that's for this 30% category. So each of those top 2 exams make up 15% of your grade. Okay? That is different from the final exam, which is worth 20% of your grade. Okay? So, yeah. Now, right, okay, so the problem, what you're probably worried about right now is something along the lines of, what is the curve? Is there a curve? If so, how does Professor Rosen curve? And the answer is I try to be as sane about this as possible. First off, in the syllabus, I make some guarantees. The curve only ever helps you because I don't think there's a reason to arbitrarily limit the number of students who get an A, okay? Simply put, I wrote in my syllabus, if you have an A, right, and that's, you know, if you have a greater than or equal to a 90, that's an A. And then elsewise in my syllabus I have, if that's greater than or equal to an 80, that's a B. I don't have a plus or minus marker on those, you know, so I'm just simply saying that above these grades, guarantee you're getting a B or an A, okay? The pluses and minuses are based off of where the grades fall. And again, it only ever helps you. So if you get a 90, you're getting an A, not an A minus. So the question is, what makes an A minus? And so what I typically do is I order the grades from highest to lowest, okay? I just simply, at the end, I just take the grades and just put them from highest to lowest. And we'll go through them, and I go through them and I look and I scroll down to where we get to the low 90s, and I get something like 90.7, 90.4, 90.2, 89.9, and I ask myself, as you probably ask yourself, is there really a significant difference between the 89.9 and the 90.2? Not really, but there needs to be a cutoff somewhere, so that's where we're going to look for so we're going to start looking for a cutoff. And so I ask the same question for the next grade. 89.7, 89.5 is like 3. There's not too much of a difference between these grades. And then maybe we get an 88.7 over here, right? And this is what happens most semesters, okay? Is that we get this high 88 grade, and then the next grade after that is 87.2, okay? So in all these situations, we can argue with different levels of certainty that there isn't much of a difference between this grade and this grade, maybe a bit of a difference between these grades, and certainly a difference between these grades, like this is half a point here. But between these two grades, right, an 88.7 and an 87.2, we can definitely see that there's a much larger gap. So what I look for is that gap, and that's where I draw that line. And so the lines occur like this. There's the first line. And that's where those lines occur. So simply put, I look for that anybody below that 90, but above that break point will get an A minus. Make sense? I use the minus. In other words, I'm using the minus to round you up, or to bump you up into the A range. So, so again, I look for that break-off point. This has basically been the kind, rather than doing a mathematical way, just looking for these gaps seems to be the most fair way to do it. And then it continues on in the same vein. If I had an 87.0, that would also be a B plus, and 86.8, right? But then if the next grade was an 85, that's where the B's would start, right? And then that would continue all the way down into our 80s, right? Now, and this is how I figure out the B minuses as well. Now, and the C pluses. Now, just to be clear, to get a 70 in this class, you need to get above 70 in this class to pass it. And if you think about it, let's just do some math right? We had, our sections are 25 points for labs, 10 points for solo assignments, 5 points for this, 5 points for the 5 points for the in-class exercises, 10 points for the final project, right? And then we have our 30 points for our exam, and then our 20 points for a final. Okay? Let's assume you do absolutely atrocious, okay, absolutely terribly on your exams, and your average on your exams is a 50. And also the average on your final exam, you also get a 50. Okay? You get an average grade for your final or your standard grade for a final project, which is 9 points out of 10. You've done most of those solo exercises. Actually, there's no reason why you shouldn't get all of them done. Okay? Maybe there was some issue with some of the quizzes, because those quizzes, again, only accounted for a small portion of your grade. And let's do the math now. Maybe not all the homeworks. 20 plus 10, 30, 43, 50 on the exams would be 15. 43, so let's go ahead and see this. So we've got 25, 34, 37, 47, 67 there. So even when you're doing atrociously on this, if you can get, I took a few too many points off there. If you can get if you've done all the homework, you pass the class essentially, even if you do terribly on the exam. Okay? If you do most of the homework and terribly, you don't pass the class. If you do okay if you end up doing most of the homework and do okay on the exams, well, not necessarily okay, but maybe in the 60s range, then suddenly that's definitely a pass, right? So as long as so what I'm trying to say is that 50% of the grade has been under your control. Basically these assignments, these demoed assignments, these solo exercises. Do not sleep on those solo exercises. I have seen a number of people who would have been A's get B's instead because they didn't do the solo exercises. Okay?
What those were again?
The textbook exercises, Runestone.
I have a question about that. So like there are exercises after the chapter?
No, just the ones that I assigned you.
And
So if you go on a Runestone, right, you log in, these assignments over here that come up, these are the ones you need to complete. Not the ones at the end of the exercises, because I select from those, right? But like when you're given when you're given calculus homework or other math homework, there's a whole bunch of problems, and they almost never tell you to do all of them, right? Right, that's exactly what's going on here. I'm just simply telling you what sub-selection to do.
oh, what about like if you scroll over at the bottom, there are like static who
These stuff? This stuff is factored into your that 5% grade, the in-class exercises.
And to get the grade, we need to
Just review the videos and review. Most of the time, I'm actually just testing for did you interact with the page and put in some code. Not necessarily does it work for those. Okay. For the reading, I check if you interacted with the pages, and for the exercises, they actually have to pass the unit tests. But if you have trouble, again, just ask on Discord or something. All right. Any other questions? I very rarely give out C minuses. It's only when I see generally the C minuses occur in like where I know that the student has been working on something or working through something. Okay, I guess I should talk about the D's and F's then, okay? I used to say I never give out F's. That's not true out anymore. Generally speaking, though, there is no real numerical kind of range for D and F. D is simply below a 70. And simply put, if you've made an attempt on everything You're definitely, you're never going to score below a D. But if I'm like missing multiple exams, or you took the exams but didn't turn any homeworks in, right? You didn't actually participate in the class, that's generally going to put you in the F range. I don't really have a numerical score. I just simply, if you tried, you got a D, right? If you made the most cursory attempt on it, you get a D. I reserve Fs for people who basically disappear and for people who cheat. So, I guess if you're sitting in this room, know that the lowest grade you're going to get is a D. Okay. Occasionally, I'll give D pluses for student, but that's not really a necessary thing usually. It's just a D. All right. Now, with regards to exam 3, this is an old practice exam, and I realize that it is woefully inadequate. So I'm going to revamp it tomorrow and then send it out so you have yourself a practice exam for exam 3. So let me go ahead, and so I've got over here, so I'm sorry, my plan today is I'm going to discuss what I have on exam 3, go through relevant questions on here, as well as show you some of the more difficult questions from exam 1 and exam 2. Make sense? So, on exam 3, I've got, let's see, a number of regular expression questions, a file reading question, let's see, how many, everything okay? I believe it's a total of 9 questions. Okay. So the first batch of questions are multiple choice regular expression questions, and those work as follows. They'll look something along the lines like this, although less abstract, right? I reserve the really nasty abstract ones for the practice exam, so I want to give you more of these to work with. But they'll look something like this. Here's a regular expression, bubble in all the things that match, right? And typically what I'll do for these is that you lose a point for each one that's incorrect. So to a maximum of 0, right? So there are 8 questions, so if you miss 5 of them, then you get 0 points on it, right? So, but otherwise I normally try to match it up correctly. But there's generally but this is one of the forms of the question where I give you a regular expression, you bubble in the regular expression it matches, okay? Naturally, one of the other ones we do is the opposite. Here are some strings. Which of the regular expressions match all the strings, right? So those are some nice, easy to grade for me questions. And those make up about, let's see, 25, yeah. I have 35 points of just simply multiple choice for those regular expressions. They're generally, and they're not all or nothing questions. They are bubble in, you get credit based on how many you get right, okay? And I don't try to be too tricky about them. This one I find is a bit trickier and nice, and like I said, it's abstract, okay? Let's see, the next question I have is a replacement question. This question will be almost identical to, it's what I told you will be on the final exam. It's going to be here too. We are basically given write a script that will replace all strings matching target, whatever that target is for the exam, social security number, telephone number, email address, write something that match some pattern, right? Write a script that will replace all strings matching a social security format, health insurance format, some pattern with redacted, right? Replace whatever I tell you to find with redacted in a given file and save that result in a new file. I went over how to do it. It's 8 lines long. The only thing that ever changes is the pattern you're looking for, okay? So that being said, the rubric is broken down such as you get 2 points for reading the file, 12 points for doing the regular expression correctly, 2 points for successfully writing it, and 4 points for doing the whole writing the substitution. So that's 8 free points if you just remember to write down that format, and so that'll be nice. Another one is a question that deals with like lists of words or lists of strings. So iterating over that. So here's a good practice problem that I'm going to keep in the practice exam that I really like. Given a list of strings, return a string that takes the biggest word from each individual string in the list and combines them together, separated by spaces. So that sounds weird, but once you see the example, it's easier to understand. So here's my sentences. There is no time left. So cute. Look at the doggy. Will result in there, cute doggy, right? Because there is the biggest word here. Cute is the biggest word in this sentence, and doggy is the biggest word in this sentence. Make sense? So, given a list of strings, you find the biggest word in each of those strings. And again, the assumption is that for these problems, I'm not throwing any punctuation at you or any capitalization or any wonky stuff like that. So, yeah, it'll be a list of strings question there. Let's see. 2 more questions then. One is another file reading question. This one actually, the one I have on this current exam 3 actually comes from a previous exam where you are reading a file and trying to figure out a couple different things, right? Remember, the way you got to work with this is that you've got a file and you need to split it up in some way, okay? Like I said, I'm going to be revamping this so that there's more relevant problems on here. And then finally, I'll have one more Monte Carlo question, which is another betting game question. It's where, again, the game is rigged against you. This one, I will mention, it is a deck of cards, okay? But because a deck of cards is, a pain to write, I give you a bit of code there, right? And I'll just simply even give you a freebie here, a bit of a freebie, okay? So I'm going to pause this. This is for people who came to the class. So resuming, it's the other bit of exam 3 over here. I do include quite a bit on, I need to fix this over here, but I do include, as I've mentioned before, quite a bit of notes on the back for you that are relevant for doing things. Such as re.sub to do substitution. That one's an important one. So if need be, you can refer back here. All right. Now let's go ahead and talk about the toughest question from exam 2. And if you're here from the future and looking back at this exam to try to study for something, good on you for being so studious and looking at stuff. This is your reward, because I'm probably not changing this question for next year, because I love this question. Okay? So let's see. So here, yep, it is alternating sums, right? I wrote on there that was the most difficult question, right? You remember this from exam 2? Right. So given a list of integers, compute and return the alternating sum of its element. So I'm going to really cause you a lot of pain right now, and lamentation and wailing and gnashing of teeth. We did a harder version of this problem on our 5th lecture. So this, if you remember, our 5th lecture was approximating pi. And we were approximating pi using the Madhavna-Leibniz series, right? You just are supposed to remember that you did Mahav of Leibniz, right? And just simply have that ready to spit back at me, right? No. But we did do that. We did do something like this. If you remember, the Madhava-Leibniz sequence was saying that pi over 4, right, is equal to 1 minus a third plus a fifth minus a seventh, so on and so forth, right? That's the Madhava Leibniz, right? Where we are alternating between doing addition and subtraction here. Now, yes, the questions aren't exactly the same, but they do share that similarity of alternating between pluses and minuses, right? There was no functions involved at the time. It was just simply one of the first couple of lectures where we really were hammering on how to do for loops. So this one is asking us, given a list, give me the alternating sum, where we alternate between adding and subtracting its elements. Now, you didn't need the BC, right? It was because that would be really frustrating, although that we can add that. We just want these outputs, right? The answer is 3 because 1 minus 2 plus 3 minus 4 plus 5. 1 minus 2 plus 3 minus 4 plus 5, right? That is 3. Here our answer was 0 because we would do 0 minus 10 plus 20. Minus 10 is negative 10 plus 20 brings us back to 0. Then to wait. The math on that is, nope, 10. Yes. Okay. I wrote a 0 here wrong. Oof. Okay, and 9 over here, right, the 9s cancel out. So, alternating sum. How do we do this one? Well, let's follow the rubric. 1, iterating over the list. So, let's go through this rubric and just kind of do this. Desktop. Okay. So, oops, forgot to say it is a desktop. Okay. Just call it alternate.py. Oh, why did I call this one? Whatever. Doesn't matter. Okay. Alternating sums. So there's our alternating sum. So our rubric is always kind of a hint for how to do these things. At least my rubrics are. Or at least kind of the order we can follow. Okay, and we read through it, it says iterating over the list, correctly setting a running sum, alternating, returning. So it's me telling you that basically that if you do everything but the alternating sum, you'd still get credit for all the things you did. So let's think about this. Iterating over the list, we know how to do this. For n in nums, right? You got to iterate over that. Now correctly setting up a running sum. Right, because even if these are adding and subtracting things, these are technically what? A running sum. And we've done those. So let's go ahead and just think about in a way easier version of this question that we've done. Given a list of numbers, what's the sum of all the entire list, right? Now, obviously because I need to be alternating, I just can't say sum nums, right? I need to do a wrap of the running sum that we've done manually, like we did in Kiva, like in the Kiva question. Call it total is equal to 0 for n in nums. Total is equal to total plus n, or we can do total plus equals n, right? So that's how we would do a running sum. Okay, alternating, that's the hard part. We're just going to quietly ignore that. And then returning, right. When we do a sum, we'll go ahead and return it. So that's 4 points right there, just for simply doing answering a different problem, the incorrect version of this problem, right? So now we need to alternate, right? What does this mean we need to alternate? There's a couple different ways to tackle it. One way you can say about this is saying, sometimes I need to be adding, but whenever I'm not adding, I need to be subtracting, right? So the question is, when do we need to do that? So I need to alternate between them. Now there's a couple ways to do this, okay? So those are the three methods that that off the top of my head, that a student would use. I would default to -1 because I'm very used to these kind of things where we use -1 to swap between positive and negative. But let's assume for a second that we've got this, right? The idea here is that we need to switch between adding and subtracting. So we could use a Boolean value to do that, right? We can say, hey, if we're not adding, we're subtracting. And if we're not subtracting, we're adding instead, right? So what we'll do is we could add a variable we could call adding or add, and we'll just say it's true. Okay? And then what we'll do is we will say, okay, and why am I setting it to true? Because what this is going to do is that this is going to let me know whether I want to add or subtract. And initially what I want to do is add the first number. And then I want to subtract the second, and then add the third. So this is one way to do this. We could say if adding equals true, we need to add. Else, we need to subtract. Now this would be sufficient for 7 points, what we have right here, because I can see that you see the logic of it, but you forgot an important step, which is that this is always going to be true now, right? The adding never changes. We call it a switch method because it needs to switch between doing two things, right? We need to switch between adding and subtracting. So if we're adding, we add the number, and then we need to set it up so that it switches for next time, so that next time we're going to subtract, which we can do in a couple ways. We can say adding is equal to false, and then whenever we subtract, we can say we've subtracted, so adding is equal to true. And I see your hand, yes.
Can we actually use a switch statement instead of if?
I mean, you could, but switch? No, switch is meant for cases, and I don't think that's really would, no. Okay, the other thing so this is a common solution I do see from students when they get to a correct answer, where it looks something like this, where you add and then you flip between whether you're adding or subtracting. Another way to handle that switching, by the way, is we can do this, and then we can say, regardless of what we do, we need to set it to the opposite. So adding is equal to not adding, and generally I don't see this from students because it requires you to really be comfortable in a way in Python that you haven't had time to get yet, right? But I figure I should show it because you should get comfortable with programming languages. The way you can flip between a true and a false is by nodding it, right? Yeah, so do the opposite. Say, I want the opposite of this. Okay, so what was my other method? Index modulo, right. Okay, so this is generally a way of looking at it that comes from being in another, in other programming languages like Java, because the default way is to use the index and iterate over the index. But it's a way that you could plausibly come up with, which is noticing that, wait a second, I'm adding the even indexes, right? Index 0, index 2, index 4. I'm adding these even indexes and I subtract the odd indexes. So I can check whether an index is even or odd to add, okay? So we're going to use, so this looks very similar. We have the total, we have this statement, but we need to change it up a minute. What we do here is that we do index for index in range len nums. That's one way to do it. Another way I like to do it, though, if I'm doing it this way, is I like to enumerate, but I'm not going to do that. That'll overcomplicate things. You could enumerate there. N is equal to nums index, right? We'll grab it out just so simply that I don't have to rewrite the n's everywhere, okay? And then rather than asking if adding is true, what we do here is that we do if index mod 2 equals 0, right? If it's an even index, we add it, otherwise subtract it. And we don't need to manually switch anything because we're iterating over the indexes. Make sense? Okay, final state for this, the final way to solve this problem is I'm going to go back to the for n in nums method, and this one ends up being a bit shorter, but you've got to be, this is, again, these are increasing levels of comfort with the language. Okay? But this is what we ended up doing in lecture 5, because we didn't know how to do if statements yet. So what we can do is we can use, I create a variable called 1, as silly as it sounds, and I set it equal to 1. And then what I do is I do total is equal to total plus 1 times n. Whoop-de-doo, Professor Rosen. What's that about, right? It's not a big deal. The big deal comes with what I do next, which is I say 1 is equal to -1 times 1. Okay? And what I'm doing here is I'm basically saying, okay, the first time it's going to be +1, but the next time it's going to be -1. And then when I multiply -1 by -1 again, it's going to be back to +1. So it keeps switching back and forth between 1 and -1. So this is another way to do it. But again, this requires you to be very comfortable with thinking about math in this way. You haven't used Python enough to think of math as a weapon or a tool in the same way, right? But I keep kind of saying that, like with a lot of the easier assignments, that mod by 10, I don't talk about it as grabbing the remainder after you divide by 10. I say you mod by 10 to get the last digit, right? You multiply by -1 to flip between positive and negative and positive and negative, right? You use -1 to flip. And so that kind of thinking is a lot more, it's a lot more, it's one of those things that comes with time. But again, the reason I show you is that if I don't show you, you won't get exposed to it. And by knowing these things, you might be feeling comfortable enough to actually try them. All right, so another problem from exam 2. Let me pause for a second. I'm unpausing. So let's see. We've got, so those are the problems that for exam 2 that I wanted to cover. For that. So once again, for exam 3, you've got a lot of questions along, and and this is part of the reason I haven't released the practice exam for exam 3 yet. We have a lot of questions along the lines of, hey, bubble in whichever these regular expressions match. About 35, 55 points are for regular expressions. So about half the test is regular expressions. Then you've got a Monte Carlo problem, a file reading problem, and a list of words problem. Okay, and so I will reflect that in the practice I send out. That being said, let's go ahead and take a look at what I currently have for the practice exam, because I'm probably going to need to go over that anyway. Because really what we've got for our last class is our review, right? We're just trying to review things. All right. So which pairs of regular expressions are equivalent, meaning they would match the same set of strings? This is when honestly, I don't like this one anymore, if this is one of the ones that's going to get axed, because a lot of those are way grosser than I would like. Write a script that, given a text file, finds and returns a list of all superhero words in it, which are the words that end with man, woman, boy, girl, or girl, such as Supergirl or Batboy. This is one we don't need to use regular expressions for, okay? Because given a text file, you find and list all the superhero words, right? You could just simply say, hey, if it ends with, you could just simply use slices to say, is the last 3 characters man or boy, the last 5 characters woman, or the last 4 characters girl, right? And then you could write that. Again, I'm probably not going to include that one. So instead, let's focus on this one. Which of the following strings does the regular expression match? So this is way more abstract and intentionally obtuse because we've got a bunch of ones and zeros, and I'm horrible like that. If I was nice, I would have done A's and B's. I wasn't nice here. I did ones and zeros. So let's think about this. So we've got a 1, and what does a star mean? Anybody remember what the clean star means? At least what? At least 0 of the preceding, right? So 1 star means at least 0 ones, followed by 0 plus. So what does the plus mean when it's attached to a character? It's very close to the clean star, remember? At least 1. So we have at least 0 ones and at least 1 0. See, I told you I was mean when I was creating this one. It says that we've got at least 0 ones, at least 0 ones followed by at least 1 0. And what does this question mark mean? So this is at least, and the question mark means optional. It means 0 or 1 of the preceding character. So we have any number of any number of ones, which could be 0 ones, that could be 1 1, it could be 5,000 ones. Then we have at least 1 0, just some number of zeros. There's got to be at least one, though. And then we've got a 0 at the end. So basically this last part is saying that the entire thing needs to end with either 1 0 or 0, right? Now, also by knowing this, we also know that this needs at least 2 zeros. So which of these does this match? We've got 0 ones in the beginning. We have at least 1 0, an optional 1. Okay, that 1 isn't there. And then it's followed by a 0. So this doesn't match. Make sense? The next one does match because we have a 0. So what we have is we have any number of ones right over here, right? We have any number of ones in the beginning. Then we've got at least 1 0, an optional 1, it's not there, and then finally it ends with a 0. Make sense? Let's look at some more examples. 1 0 1 0. At least 0 ones, yes, that's at least 0 ones, followed by at least 1 0, followed by an optional 1, okay, the one's there that time, followed by a required 0. Make sense? Okay. How about this one? All right. It can start with any number of ones, right? There aren't any, though. That's fine, though. At least 0 ones. Followed by at least 1 0. Well, there's 4 of them. That counts as at least 1. Followed by an optional 1. It's there. Followed by a mandatory 0. Yes. So this doesn't match, and the way we find out it doesn't match is we can say, hey, we have at least 0 ones, we have at least 1 0, but then we don't have that optional 1, that's fine, but we don't have a 0 after that, so that fails. This one also fails. Why? Because we have at least 0, right? We have at least 0. We have at least 1 0. Yeah. And we have our 0 at the end, but this question mark says there can only be 1 between those zeros, right? It's an optional 1. Make sense? Now let's look at this one. Any number of ones. Cool. At least 1 0. Yeah, we can grab at least one 0, followed by an optional 1, sure. Followed by a 0, yes. That works. How does it know? It's greedy. It will always try to find a solution if a solution exists, right? Yes.
There are more correct statements.
Yep. And what I'm caring about is whether it's bubbled correctly or not bubbled correctly, right? So I would care. I care basically, are you getting them? Basically, they're true-false questions.
What if I bubble everything?
Then you would get points off for the ones that were incorrectly bubbled.
I get negative number of points?
No, I'm not that mean. Sounds hilarious though. So I have, like I mentioned, a number of questions that look, we will do a number of questions that look like this on the exam, and I plan on giving you more on the practice exam with ABs, right, or CDs or something like that, rather than giving you at least 0 1s followed by at least 1 0, because that's mean, because I'm using 1s and 0s a lot there and in different contexts, and it's just wrong. Right, but the ones, but what it is also that doesn't necessarily, messing with 1s and 0s like that may be fun, but it also gets in the way of the thinking of the actual problem I want to solve. All right, so we looked at this problem, but let's go ahead and look at how to solve it. I will have it on the practice exam so you can try it again yourself. Given a list of strings, how much time do I have? Oh, good, plenty of time for this. Given a list of strings, return a string that takes the biggest word from each of the individual strings in the list and combines them together, separated by spaces. See the example. So as I mentioned, there's no time left, so cute, look at that doggy, should give the output there, cute, doggy, because there is the biggest here, cute is the biggest here, doggy is the biggest here. Any questions as to how I arrived at that answer? And yes, I did start with their cute doggy and kind of work backwards from there. So let's go ahead and take this one, big sentence, right? Oh, I forgot to add a comment to that top one, but that's okay, because here we go. So the first thing we need to do is we need to figure out what our inputs and what our inputs and outputs are going to look like, right? We've got this list of words, and our output is going to be a single string. And so we can figure out how we can build this string, this output, because we're going to have to take this output and return it. This output we can create by concatenating the biggest word from each of these strings. So we go through each sentence, we figure out what the biggest word is, and then once we figure that out, we add it to our output. So first thing we have to do is go and say for sent in sentences, right? Go through each of these items in our list. Now each sentence has to be broken up into words in order for us to solve this problem. So we're going to look for the biggest word in the sentence. So we're going to say biggest word is equal to nothing. And then we're going to say words is equal to sentence dot split. And we're going to split it up again on spaces. So we take our sentence and we split it up into words. We know we can do it like that because I don't have to worry about punctuation. And we know that by definition in English, every word has a space in between them. Right? You're only ever going to be splitting by one of two things. You're either going to be splitting by spaces for words, or you're going to be splitting by commas for comma-separated values. Make sense? Right? For CSV files, where things are listed as data, comma, data, comma. All right, so words is equal to sent.split. For word in words, so for each word in words, we need to figure out if that's the biggest word. Okay, and how do we do that? We ask ourselves, if the length of the current word we're looking at is greater than the length of the biggest word, right? I could create variables for those, but I don't need to. Easy enough to write a len around those. So if our word is bigger than the current biggest word we found, what we'll do is say biggest word is equal to that word. And that will just continually update, right, to find out what the biggest word is. Right now, this starts out at 0, so by definition, anything's going to be bigger, and then we'll update as we go through. Now, the next part is once we found the biggest word in that sentence, right, we need to add it to our output. So we're going to say output is equal to output plus word. And that's pretty much it. However, what that would produce, honestly, this would I'd probably ignore this and give you 10 points because it's one of those things that's easy to correct. Because what you have here is our output in this case would be their cute doggy. Right? And that's easy, that's hard to remember that you've got that on tests, right? So I wouldn't necessarily take off for that. But to do it correctly, what we would need to do is we would add a space after every time we added a word, so it would split up. And that gets us into our own fence posting problem. But again, we don't really need that. The important part was to add is that once we figured out biggest word. Once we figure out the biggest word, add it to our output. Figure out our biggest word, add it to our output. Okay. Let's see.
I have two questions.
Yes.
One, where can we find this practice exam?
This is one that I'm gonna be remaking and sending out tomorrow to add more relevant questions to it.
Okay, and two, when is
When is the
the exam?
exam? Excellent question. So, it's one I don't mind answering as many times as I have to. So for this one, your exam, I am giving exam 3 at the last possible date, which is going to be in your lab. It's going to be either on the 25th or the 28th, unless of course you want your lab to actually work on you want time to actually work on your labs in lab, in which case I can give it next week on the 24th in class, but I don't know if you want that. Right? You'd prefer it in lab? Right. So 25th and the 28th. Yes, that the final project is due on the 28th as well, but I have to turn it. If I could make it due later, I would. Yes.
For the final, is the sheet of paper still acceptable?
Yes.
Okay.
Yes, the sheet of paper is still acceptable for exam 3 and the final exam. So it will be done in lab, and I'll basically try to get it graded as quickly as possible with that. Once again, with the final exam, I'll just simply say this again in case you missed it. We do have 7 questions. You choose 5. And we have, let's see, list of lists. We have the so we have list of lists. We have file reading, regex, Monte Carlo. Let's see. Oh, right, turtles. So another loop question with modular arithmetic. Okay. And then finally, the mystery question. Okay. So this one goes over a list of lists, right? I like list of lists because they are, they're not that hard to do. One year I did a fairly simple one, which was, what was it? Yeah, it was, here's a list of numbers, right? Here's multiple lists of numbers, okay? I want all of the, give me the sum of all the positive numbers. That's it. Just a list, just multiple lists of numbers in a single list. Give me the sum of all those numbers. File reading, you've done something like that. In fact, I showed you one today that was very similar. I believe I showed you one today that was one I used in the past. Let's see. It'll be very, this will be very common, this will be very similar to what you see on exam 3 and on the final. The one on the exam 3 and final will be very similar to each other, which are, here's a CSV file, right? And I want you to just simply iterate over it and like add up the relevant fields or tell me what the biggest of a field is or something like that, right? Or only, as you saw in exam 2, only add up fields if another field has this state. For that one, again, you're just going to need to go line by line and split. Regular expression, same as on exam 3, right? So replacing Social Security, replacing phone number, something like that. Monte Carlo, as I mentioned on Tuesday, on exam 3, it's a fairly, it's a easy to understand gambling game, because gambling games that are scams need to be easy to understand so that the mark doesn't question the why they're losing. They just think it's bad luck. Okay, so it's got to be simple enough to understand. On the final exam, we will do a problem that is simulating a game that is literally made for toddlers, as I said. That's not meant to be insulting, because it's just simply meant to say that the rules are actually fairly easy to understand. Okay? Rules are fairly easy to understand. So turtles. That one is going to be given code for turtle. Draw this thing. It's not going to be an intricate like picture, right? I'm not going to make you have to connect the dots. Although that sounds like a great question to do. We have a this loop modular question. If you know it, if you know the one I'm talking about, you know the one I'm talking about. The only hint I'll give is that one's based off a drinking game. And then but basically what you need is you need to use modular arithmetic correctly to basically get the appropriate outputs. And then the mystery question again is not one to be scared of. It's probably the easiest one on the exam if you've been keeping up with class, because it's just simply, here is thing to solve the problem. Here's how to solve the problem. Sorry. Here's a thing. Here's a common problem we solve with it. Solve it. A harder version of it might be like, if I hadn't taught dictionary and I give you a list of all the dictionary functions, right, that you would need to solve a word count problem. That's what it would be like. If you didn't have the dictionary, I introduced the concept of dictionary, gave you all the information on how to use it to solve that specific problem, and no extraneous information, right? That's the important thing. I wouldn't give you any extraneous information. And then you use it to solve the word count problem or a letter count problem. Okay? So not to be scared of.